Chapter 5.2, Day 1, we're looking at properties of rational exponents and radicals. In this section, though, we're going to focus mainly or only on exponents. Let A and B be real numbers, and let M and B be rational numbers, such that quantities in each property are real numbers. So this is just our rules on exponents, and not rational exponents, but just regular exponents in this case. Rational means fractional exponents, and we're not looking at fractions right now. So we have product of powers when you have a raised to the m times a raised to the n. So if you have the same base, what you can do is you can add the exponents. So in this case, we have 3 squared times 3 cubed times 3, and so we can add all the exponents together. Now remember, there is an invisible 1 here. So this is 2 plus 3 plus 1. So this ends up being 3 to the 6th. Power of a power, so remember when you do, what you do here is you multiply the exponents together. So a raised to the m times n. So in this case, this becomes 2 raised to the 2 times 3, which is 2 to the 6th power. Next we have power of a product. So what we can do here, when you have a times b raised to the m, we can distribute that exponent to both things inside. So a to the m, b to the m. And then so we'll do the same thing just to apply this same property. So here, this is going to be 2 cubed times 3 cubed. And that's all we need to do, right? We don't have to evaluate that all the way. Negative exponents, remember with this, when you have a negative exponent, you write the reciprocal, and it's only to what it's attached to. So it's in the numerator currently, so if you don't see a number at the bottom or anything, then you just move it to the other side of the fraction bar. So that becomes 1 over a to the m. Now here's another example. If I have 1 over b to the negative n, so if it's in the denominator, it's going to move to the top, to the numerator. So in this case, with this negative exponent, we have 2 raised to the negative 3. So that means that we move the 2 to the denominator, 1 over 2 to the 3rd power, and once we move it, it becomes positive. Then we could evaluate it all the way. So this is 1 over 2 times 2 times 2, which is 1 over 8. Zero exponent, anything raised to the 0 power equals 1, and so 6 to the 0 power is 1. Again, it's important to remember that it's whatever it is attached to, what it belongs to, and that's the only one that changes. Quotient of powers, we have a raised to the m over a raised to the n. Now what you can do with this is that since it's the same base, we can subtract the powers. So you have a raised to the m minus n. So in this case, we have 3 cubed over 3 squared. So we can just subtract the exponent, so 3 minus 2, so that becomes just 3 to the 1st power, or just 3. Power of a quotient. So what we're going to do with this is we can distribute this m to both the a and the b. So this is a raised to the m over b raised to the m. And another important thing about that, more than anything, is that we can go the other direction as well. So we're going to see this where we're going to see this property where we have a to the m over b to the m. They have the same exponent. So what we can do is just use this power of a quotient property, put it to the outside, and then do the a over b. For this example, what we can do is we'll apply the same property here. So let's go ahead and distribute that. So this is going to be 4 to the 3rd over 7 to the 3rd. And then we could distribute it out just to kind of get used to seeing the numbers. So 4 to the 3rd is 64. 7 to the 3rd, that is 7 times 7 is 49. 49 times 7 is 343. Okay. So let's do a little bit of practice. Let's do product of powers. Now the first row, or maybe the first 4, are really just kind of the warm-up to what Algebra 2 is supposed to look like. So remember that our chapter is on rational exponents. So really number 5 and 6 is really what we need to be able to do. 1, 2, 3, and 4, those are okay, but it's just like the basics of what we need to understand about exponent rules. So with 2 to the 4th times 2 to the 5th, remember you can just add the exponent. So this is 2 to the 9th, and we don't have to multiply it out. And then, so I'm sure you could do number 2, 3, and 4. Number 5 is the same. So remember, you apply the same properties. Now you just have to add fractions together. And remember about the rules about getting a common denominator. So try these out. The first, all of these, 1, 2, 3, 4, 5. All right, if you tried this out, number 1, we did number 1 together. Number 2 is w to the 14th. Number 3 is 4 to the 8th. So don't forget the 1 here. So then add it together. Same thing for number 4. That becomes 8x to the 13th. Now, number 5, you should have gotten 5 squared, or 25. And number 6, you should have gotten 7 to the 3/4. Now, let me go ahead and work this out together. So remember, when you have the same base, you can add the exponent. So it's 1/2 plus 3/2. And it looks a little different just because we have fractions, and that's okay. But we can just add the fractions like we normally add fractions. So if it has a common denominator, that's fine. I don't have to do a lot of work with that. I just add the numerators together. And so this becomes 5 raised to the 3 plus 1 is 4 over 2. And what is 4 over 2? Well, 4 over 2 is 2. So therefore it's 5 squared. And then we could go ahead and change it to a regular number without an exponent. We could say it's 25. Number 6, we do the same thing. It's 7 to the 1/4 plus 1/2. And so currently, when we're adding these exponents, they don't have a common denominator. So in order to do that, we're going to multiply the 1/2 by 2 over 2 because 4 would make it a common denominator. So now this becomes 7 to the 1/4 plus, and this becomes 2 over 4. Then we add the fractions together. Remember, the numerators get added together and you keep the denominator. So this is 7 to the 3/4. Then I want you to notice I have this MA here. So when we multiply, we add the exponents.